Morning. Welcome to Algebra 1. It's good to hopefully have everybody kind of in place this Monday morning. If we haven't met, my name is Mrs. Stanley, and I look forward to officially getting to meet you all tomorrow in class when we have our live session. Today we're going to be looking at two sections, section 1.2 on evaluating linear equations, and then section 1.3, graphing linear equations and inequalities. So we're going to kind of get through some of this stuff today. If you need to slow down as we're going through, feel free to pause, practice, and then pick back up. That way you are set and ready to go for your checkpoint at the end of today's lesson. Okay, so in the OHS, I'm going to have this link for you guys. This is a game that you can play that is going to help kind of refresh your memory on the coordinate plane. So you have your link here. I'll put that in the OHS for you. But just a few reminders about graphing. So when you have a coordinate plane, and a coordinate plane, if you'll remember, is when you have like your y-axis and your x-axis that cross. This is a coordinate plane, and you have a lot of times you have all the tick marks to show like 0.1, 2, 3, 4, and so on and so forth. So when we name a location, we use x comma y. The x coordinate always comes first, and that is your horizontal axis. So if you're moving in the left or right direction, you're moving in the x direction, and if you're moving up and down, that is your y direction. So that's just a little bit of a refresher on graphing and where to put your points in the coordinate plane. Today we have 4 learning targets. The first is that I can draw graphs of lines given the linear equation. So we're going to focus on that first. We're going to then go into I can find the x and y intercepts of a line given the equation of a line. Now the third one, I can determine the slope of a line given the graph or equation. And then lastly, I can graph lines on the coordinate plane in slope-intercept form. So we're going to go ahead and take a look at some examples of each of these targets so that by the end of the session you have a good foundation for graphing. Some of this might come as review to some of you, and others of you might need to spend a little bit more time with the material, so you do what you need to do. All right, so our first learning target, I can draw graphs of lines given the linear equation. So what do we need to know? Any straight line can be drawn with just 2 points. You can use the equation to generate, or you can use the equation of a line to generate any of the points on that line. So if you'll remember, we have an x value and a y value for each coordinate, and that x value is the input, and then my y is the output. So we pick an x value, we pick the input value, and then that's going to give us our output value. So here is my line. You can see that graphed here in red, and every point that's on this line is considered a solution to that equation. So this point is at negative 1, 1 right here on the graph. Kind of highlight that a little bit. So that means that I can evaluate the equation of this line at x equals negative 1. This is negative 1 on the graph, and I'm going to get an answer of 1, which is my y value. So notice when I graph those, that's how those two parts relate to one another. So we're going to take a little bit more of an in-depth look at how we're going to get those points and how to graph them to make our lines. Okay, so in this first example, we are going to graph the line y equals 5x minus 2. So to do this, we're going to find any 2 points on this line by plugging in numbers for x in the equation. So a great way to do this is to make a table. So I have my x and my y coordinate. Remember, this is your input and this is your output. So we're going to input numbers for x to figure out what my y is going to equal, or what my output is going to equal. So I'm just going to pick 0 and 1 as 2 points because they're pretty easy to work with. So if I start with this equation here, I've got y equals 5 times, and I'm going to plug in that input of 0. So I'm going to plug in 0 for x, and when I do that, I just end up with 0 minus 2, or negative 2. So that is my output. That is my answer for y. And then I can come over here and graph the point 0 on the x-axis, and then -2, so down 2 on the y. There's my first point. Then I can go ahead and do the same thing. I'm just going to change my colors here just for the sanity's sake so you can see this a little bit better. So then I'm going to have y equals 5 times 1 minus 2. And when I simplify that, I get 5 minus 2, or 3. So my output, when x equals 1, my output is 3. So I go over 1 on the x-axis and then up 3. Now that I have my two points in, I can go ahead and graph my line. And excuse me for my horrible, I'm not the best at drawing. Oh, really? What is that all about? Come on, pen tool. Hold on a second as I scribbled everywhere. 1, 3. All right, so when I go ahead and try to draw in a straight line, that's about as good as I'm going to get. We can see our line right there. Okay, so what this means is that any point that's on this line is a solution to this equation. So if I went up and plugged in 2, for x, I'd get my next point that would fall on the line. And then 3, I'd get my next point that fell on this line. Okay, but you only need 2 points to make a line. All right, if you'd like, now would be a great time for you to pause, try this one on your own, and then come back and check your answer with me in a minute. I'm going to go ahead and keep working on this one. Oh, I forgot. There's a little bit more here. So we're going to do the same thing we did before. So we're going to find any 2 points on this line by plugging in numbers for x into the equation, just like we did. And I'm going to pick the same 2 points just to kind of show you a couple things. So I've got my x and my y, and I'm going to use 0 and 1 just because I think they're easy to work with. So if I start with this first one, remember we're plugging in 0 for x, okay? The points we pick are the x values. Those are the inputs. So I'm inputting 0 to find my output of y. Now, if you notice in this equation here, we're going to have to do a little bit of work to figure our y out. It's not quite as straightforward as the last one. So when I plug in the 2 here, this is going to eliminate that part of my equation here, because 2 times 0 is just 0. I don't need to work with that anymore. So I'm going to have 3y equals 10, and then I have to divide both sides by 3 to get my y value. And we know that when we have a fraction like this, we can just type it in and get a decimal output. So that's what I'm going to do this time. And 10 over 3 is going to give me 3.33 repeating. And I'm going to go ahead and put that up here for my y coordinate, and then I'm going to come over and graph it. So my x, on the x-axis, I'm going over 0, so I'm starting at 0, and then I'm going up a little bit over 3. So there is my point there, okay? Now I'm going to do the same thing again, but this time I'm going to use my input value of 1 for my x. So 2 times 1 equals 10. So 2 times 1 is 2. And now I have an equation that we have to solve for y. So since I have this plus 2 to undo it, we subtract both sides by 2. So 3y is going to equal 8. And then we can divide both sides by 3 because this was multiplication and those will cancel. Now 8 over 3 as a decimal ends up being 2.66 repeating. So when I go to my graph and I try, it got rid of my point again. There's my point, and I'll do my orange point here. So this time I'm going over 1 and then up 2.66, so a little bit over 2.5. There's my second point. Okay, and now we can take those 2 points and we can draw in our line. So this is about as good as I can get. Again, if you're doing this by hand, it's a lot easier to do to make it look pretty and straight. So now once you have your line graphed, you can evaluate other points to see if there's solutions to the equation. And there's a couple ways you can check. If you have a nice, neat graph, you can check by just looking at the graph. So here I have, is the point 1, 3 a solution to the equation? Well, it's not, because we already figured out that the input of 1, that it corresponded to 2.66, okay, over here. So we know that this guy is not a solution. But then it asked me, is the 0.50 a solution to the equation? So according to my graph, it's not. It's a little bit less than 0, but we could just double check quick by plugging it back into the equation, because my line isn't like perfect here, so I just want to make sure. So if I were to plug in 5 for x, we want to know, are we going to get 0 for y? Okay, so is y going to equal 0? That's what we're trying to test if I want to see if this is a solution. So if I simplify that, that's 10 equals 10. I still have this 3y. So when I move the 10 over to get y by itself, I end up with 0. When I divide both sides by 3, 0 divided by any number is just 0. So this is, in fact, a solution. We just couldn't see it that clearly because my line isn't drawn very straight. So this is where, if you don't have graphing technology and you're doing things by hand, it's always a great idea to check algebraically. So really, this line should, if this is also a point, we know that 50 is going to be a point on the line, my line would actually come up a little bit more like this. It's just hard for me to do it by hand in here. Okay. All right, so that takes care of the first learning target. We're now moving on to the second learning target. I can find the x and y intercepts of a line given the equation of a line. Okay, so when we're trying to find the x-intercept or the y-intercept, if you'll notice the x-intercept, okay, so here, notice I've gone over -4, but I haven't gone up or down at all. And no matter where I am on the x-axis, if I'm going through the x-axis for my x-intercept, I'm never moving up and down in the x direction. So I will always have some number x, and my y value is always going to be 0. So always going to be 0. Where my y-intercept, if here at 2, if I go up or down anywhere on the y-axis, I haven't moved left or right at all. So when I'm going to find my y-intercept, my x value is always going to be 0. Okay, so you just need to remember, when you're trying to find your x-intercept, y is 0. When you're finding your y-intercept, x is 0. And this is a little graphic here, visual, to show you why that is. So in example 3, it says find the x and y intercepts of the line y equals 5x minus 2. So what we like to do is we want to plug in. We know when we're trying to find the x-intercept, we want y to equal 0. We just talked about that. And then when we want to find our y-intercept, we want x to equal 0. So I can take my equation, my y equals 5x minus 2, and I can substitute in 0 for y and x, depending on which intercept I want to find. So to start, if I'm over here trying to find my x-intercept, I'm going to plug in 0 for y into my original equation. So I just substituted in that 0 for y. So 0 equals, oh, I already did that. I don't need to simplify anything. So I want to get x by itself, so I can go ahead and add 2 to both sides. So those cancel. 2 is going to equal 5x. Divide both sides by 5. And I'm going to flip-flop here. So x is going to equal 2 over 5, or as a decimal, that's going to be 0.4. So a little bit under a half. And then I'm going to do the same thing over here for my y-intercept, but this time I'm going to let x equal 0. So y is going to equal 5 times 0 minus 2. Anything times 0 is 0. So when I simplify this, y is going to equal -2. So my points, if I'm actually writing my coordinates, this coordinate is going to be 0 for my x, -2, and then this coordinate would have been, if I use the decimal form, 0.4 comma 0. So those are my intercepts. So if we actually graph this to check it, we can see that we are correct. Okay, because right here, this piece here is going to be my y-intercept because it's going through my y-axis. And we can see here my y-intercept 0, -2. Here I am. I went 0 in the x direction, but down 2. And notice here my units, this is 1 all the way over here, and it's broken up into 5 parts. And I've gone over 2 of the 5 parts. That's the 2 over 5, or 0.4. I haven't gone up or down at all, so this is my x-intercept. And we did that correctly. All right, so if you would like to try one on your own, now would be a great time for you to pause, try to find the x and y intercepts of this line on your own, and then check your answer at the end. I'm going to go ahead and go through the same process here. So when I find my x-intercept, we're going to let y equals 0. So if I start with that, I'm going to have 3 times 0 plus 2x equals 10. 3 times 0 is just 0, so that's going to eliminate or cancel out. Oops, that's a 2. So I've got 2 times x equals 10. We divide both sides by 2, and x is going to equal 5. So my first point here that I found, my x-intercept is at 5, 0. Okay, remember we were finding our x, we plugged in 0 for our y. Then we can do the same thing with our y-intercept, but this time we let x equal 0. So I'm going to do the same thing, but put in 0 for x. 2 times 0 is going to cancel because anything times 0 is 0. So 3y equals 10. We need to divide both sides by 3 because this was 3 times y, so to undo that multiplication. And y here, we can keep it as a fraction, or we could simplify it as a decimal. So this is going to be 3.33, repeating. So my y-intercept is going to be 0, 3.33. Okay, so we're going to check to make sure that those 2 points are correct. So when I graph these, and I'm going to rewrite this since that came right over my answer there so we can see, see it a little bit better. Okay. So my y-intercept, that's going to be on my y-axis right here. Remember, this is my y-axis. And we can see this is 2 and this is 4, so that right in between here would be 3. Okay, and I've gone a little bit above 3, so that looks correct for my y-intercept. And then my x-intercept, I've got 4 and then 6, so right in between is going to be 5, and 5, 0 was in fact my x-intercept, so we did that correctly by checking it graphically. Okay, so that takes care of our first 2 learning targets. We learned how to graph a line, finding 2 points, and then we just looked at how to find the x and y intercepts of an equation and then also check them graphically. So the third thing we're going to do is to determine the slope of a line given the graph or the equation. So let's take a look at what this looks like. So what is slope? So slope is the steepness of a line. It can be negative, it can be positive, it can be 0, or it can be undefined. It is the ratio of the change in y to the change in x. So you can see here we've got it written out in algebraic form. So slope is the change in y, and change just means like the difference. You subtract your y's to find the change. So here's the official formula that you'd see. y2 minus y1, that's the change in y over the change in x's, and that would be x2 minus x1. Another way to write it is rise over run. When we do it graphically, I often refer to rise over run. So this is on your formula sheet for the milestone. This is not a formula you'll have to memorize, but it's one that you might memorize because we use it a lot in algebra. All right, so how can I tell if a slope is positive, negative, 0, or undefined? So we have slope dude here in this little image. So if you're skiing, this is kind of a way of thinking about visually what's going on with slope. So if you're starting from left, you always start from left to right because that's how we read a graph in terms of a line and the slope. So if we're going from left to right and we reach this mountain here, if I'm going uphill on the mountain, we say puff, puff, positive because, you know, it's a lot of work to climb up that hill. If you're cross-country skiing, that would be a lot of work to get up. So hence the puff, puff. And then going downhill, this is nice, negative, because it would be super easy to coast down that hill once you are on those skis. Okay. Then if you had a straight part of the course, let's say you're cross-country skiing, we say this is 0 fun because it would be a lot of work. I mean, not as much as going uphill, but it's still a pretty good exercise here. So we say that that part is 0. So when I have a horizontal line like that, the slope is 0. And then when I go downhill, we are undefined. Okay, so this is when I have a vertical line. So I'm going to write some of these terms here. So slope is positive when I am going uphill. Slope is negative when we're going downhill. Slope is equal to 0 when I have a horizontal line. And slope is undefined when I have a vertical line. Another way to look at this too, when you have a horizontal line, a line like this up here, this could be like y equals 3. If I don't know what my scale is, but I'm just kind of approximating. So anytime you have y equals a number, your slope is going to be equal to 0 when you have that horizontal line. As opposed to when I have a vertical line, like if this was, let's say, x equals 4, this is going to be a vertical line and my slope is always undefined if I have x equals a number. So those are kind of our standard rules for our lines and the slopes of each line. All right, so when we try to find the slope from a graph, we're going to use the idea of rise over run. This is much easier to do graphically. So rise, we're looking at our change in y's, and remember that run, we're looking at our change of x's. So if we look here at the graph that they give us, notice that this graph is going downhill. So when I find my answer, I should have a negative slope. So you might even want to write yourself a little note, okay, this should be negative when I get my answer. And if I don't get a negative slope, then maybe I did something wrong. So we want to pick 2 points on the graph. They give us these 2 points here in red, but those are quite far in terms of spacing. So I'm going to go ahead and pick this guy right here because it looks like it's going through exactly at that point. So you just want to find something that's going through a whole number part. Okay, we don't want to use any decimals if we don't have to. So it's -1, 0, that's that coordinate. And then this coordinate down here is over 3. And then it looks like it's down 1, 2, 3, 4, 5, down 5. Okay, so there's my 2 points on that graph. So now I'm going to go ahead and we are going to count my rise over run. So rise is the change in y. So if I start up here at this point, I want to see how many did I have to move to get down to this point down here. So I went down 1, 2, 3, 4, 5. And since I went in the negative direction, that's actually -5 units down. Okay, so that is my rise. It just happens to be negative. I know sometimes when you think of the word rise, you think of a positive thing, but we're really kind of falling in 5 units. So then from this point where I started at to get to this point over here, I want to know how many do I have to run. So in the x direction, how many spaces do I need to move? So starting at that same point, I have to go over 1, 2, 3, 4. So there is my run. Rise over run. And then we just write it as a fraction. So -5 over 4. And that is my answer for that number 4 there on the graph. All right, so you could keep practicing all of these. I'm going to go ahead and move down to one of my positives here just to kind of illustrate this as well. So it looks like we've got a nice point right here at 2, -2. And then I have this guy here at 1, -5. So again, I'm just going to count my rise over run. So if I start at this bottom point, I'm going up 1, 2, 3, and I'm going over 1. So my slope will be positive 3 over 1. And I know it's positive because it's going uphill from left to right. All right, so that's just taking a look at a couple of those. I'm not going to go through all of them because hopefully you've got a good idea. This is something we did a lot of first semester. And if you have more questions about this, we can use some of these examples at a later time to go through together if needed. All right, so how do I find the slope given 2 points? So in this example here, we, instead of being given the graph, we are given 2 points right here, and we want to find the slope. Well, we have the slope formula. We talked about that briefly towards the beginning of this target, and that's y2 minus y1, the change in y's over the change in x's, or x2 minus x1. So when I'm given 2 points like this, what I like to do is label my points. So I'm going to let this be x1 and this be y1, and then I'm going to let this be x2 and y2 for my 2 points. So that when I'm plugging my values into my formula, I don't make any mistakes, because sometimes my brain plays tricks on me. So this way it kind of helps keep things a little bit neater for me. So my y2 is 8. So I'm going to use that 8 first, and then it's minus y1. And my y1 is -6. So make sure that you put that negative in there because that matters. You can't just drop it off because the formula has a minus sign. And then we're going to move on over to my x's. So my x2 value that I chose was 4, and then I'm going to subtract my y1 value, which is -3. Now keep in mind, I could have labeled this x1 and y1 and this x2 and y2, and when you plug in the points and do all the work, you're going to get the same answer. So I just want to, because some of you might practice that way or label something similar, you just have to stay consistent. So if this is your second point, you have to keep it your second point, but the flip-flop part, that doesn't matter. That's just a little quick aside. So back to this. When we do the top, I'm going to simplify. When I have 2 negatives like that, 2 negatives we know make a positive. So 8 plus 6 is 14. And then same here, I've got 2 negatives, that's going to make a positive, and 4 plus 3 is 7. And 14 over 7 gives me 2. So my slope, we call that m, that slope is 2. Now you could, in theory, go ahead and graph this to check. You could graph your 2 points. This is just another way that you could do it. So you could go down, over -3 and then down 6. 1, 2, 3, 4, 5, 6. And then my other point is at 4, 8. So over 1, 2, 3, 4, and up 8. 1, 2, 3, 4, 5, 6, 7, 8. Okay, and then you could graph it and then count and do your slope that way. And you'd probably end up with 14 over 7, and then that would simplify to 2 if you were just to count those 2 points. So that's what we're doing algebraically, but you could also do it graphically if you had a graph and that was easy for you to do. So if you need some more practice on this, now would be a great time to pause and try this on your own. I'm going to go ahead and just go through this one quickly so that we can do one more example with the slope. So I've got my y2 minus y1 over x2 minus x1. And again, I'm going to go ahead and just label my points. That doesn't look like an X. There we go. Okay. Then I'm going to fill in my pieces. So my y2 was 4 and my y1 is -6. Don't forget the negative. And then my x2 was 6 and my x1 is 4. So my 2 negatives make a positive. So that's going to be 10. 6 minus 4 is 2 and 10 over 2 is 5. So my slope is 5. Again, if you wanted to check it graphically, you could by doing the rise over run to see that you got the same thing. Okay, so in this example, we want to find the slope of the line y equals 5x minus 2. All right, so the first way here, it says find any 2 points on this line by plugging in the numbers for the equation. So we can go ahead and use our table form, x comma y, and I can pick 2 points. So again, if I pick 0 and 1 because they're simple to evaluate, I'm plugging those in for x. So if I plug in 0, remember this is just going to cancel, so I'm left with -2. That would be my first point. And then my second point, when I plug in 1, I'm going to have 5 minus 2, or 3. So now that I have my 2 points, I have 0, 2, and I have 1, 3, I can plug those into the slope formula to find my slope. So x1, y1, x2, y2, and we plug it in. So my y2 is 3, and my y1 is -2. My x2 is 1, and my x1 is 0. So these two negatives make a positive, so I'm going to have 5 over, and then 1 minus 0 is 1. 5 over 1 is just equal to 5. So my slope for this equation is 5. Okay, we can also use the graph of the line to find the slope. Okay, that's what we have going on here. Here's my 2 points, and then we could count up 1, 2, 3, 4, 5 over 1. We can see that we have a slope of 5. Okay, so there's a horizontal distance or a run of 1 unit between the points, and then there's the vertical distance or rise of 5 units between the points. And then you plug that into the ratio of 5 over 1. Okay, so that's how those two coordinate with one another. Okay, so we're going to do the same thing with this equation. So find the slope of the line 3y plus 2x equals 10. So we want to find any 2 points on the line by plugging in numbers for x into the equation. And then we're going to use the slope formula again to see. I'm going to see what points they picked so that our graph matches here. So my x point here that I'm going to pick -1 this time, and I'm going to pick 2. I'm just doing that so that my example matches. I know before I was using 0 and 1, but you could really pick any 2 points. So if your favorite number is 5, you could use 5 and 6. I wouldn't use huge numbers because it just makes things a little bit more messy. I would keep things in like the -3 to +3 range, just for the sake of simplifying your problems. So when I start with this first one, I've got 3y plus 2 times my x value, which is -1. I'm going to simplify that. So 2 times -1 is -2, and I'm going to rewrite the rest of my problem. And then we're going to solve. So I've got -2, so to undo that, we add 2 to both sides. So 3y is going to equal 12. And then I divide both sides by 3. So y is going to equal 4. So my first point is -1, 4. That's my x1 and my y1. Now I'm going to do the same thing. I'll do a different color just so we don't get lost in our work. So 3y plus, actually plus 2 times 2, because that's my x value, my input that I'm using this time from over here. That's the number I picked. So 3y plus 4 equals 10. This time I've got a plus 4, so I'm going to subtract 4 from both sides to undo that. So 3y is going to equal 6. 10 minus 4 is 6. Divide both sides by 3. Y equals 2. So my second point is 2, 2. That is my x2 and my y2. And now I can plug those values into my slope formula. So I've got my y2 is 2, and my y1 is 4, and then my x2 is 2, and my x1 is -1. So make sure you use that double negative there because that's going to turn into a positive. So I'm going to have 2 minus 4 is -2, and then 2 plus 1 is 3. So my slope is -2 over 3. And we can see here when we're doing this that there's a horizontal distance or a run of 3 units and then a vertical distance of 2, but I fell. I'm going downhill. So there's that 3, and then here is going to be that -2. So my rise in this case is that -2, and my run is that +3. All right, so that was an overview of how to find slope. So we looked at how to find the slope on a graph, and then we looked at how to find the slope given 2 points, or if we had to find 2 points, and then use those 2 points to find the slope. In this last learning target, we are going to look at how to graph lines on the coordinate plane from slope-intercept form. So this is going to kind of put everything together, and this I think is a little bit easier than doing all of the little individual processes that we went through before, but you still need to know how to do slope and all that jazz for what's coming up later. All right, so what you need to know, slope-intercept form. Hopefully this is familiar to some of you. Your output value, that's your y, that equals mx, so m is your slope, that's what we just learned how to find with 2 points. And then we have our input value of x plus b. So when we're given a problem like this with slope-intercept form, we're going to have a value for our m, our slope, and we're going to have a value for our b or our y-intercept. And that's how we're going to be able to graph lines in slope-intercept form, given the slope and given the y-intercept. So here's an example. So y equals 3x minus 5. So steps to graphing from slope-intercept form. So we always plot the y-intercept first. So the point is 0, b. Remember to carry the sign with b. I always say that b means begin here. Okay, this is something you'll hear me say a lot. Begin here. So we begin with b always. So then starting from the y-intercept, so starting from this point, so in this case, my y-intercept is this -5. That's my b. So starting from that point, if I were to graph that, I would then use my slope, my rise and run, to graph my next point. So if the slope is negative, remember that you're going to rise down or you're going to run left. You have to go in the negative direction, but you don't do both. And then you're going to plot the point that you land on. Then you're going to have 2 points. You'll be able to connect the 2 points with a straight line. And I'm going to show you how to do it in a minute. So here's the first example. Graph y equals -2x plus 3. I have my y-intercept formula all over here broken down for us, and then the steps are right here as well. So remember, we always want to begin with b. So what I like to do is start by identifying, okay, what is my b? Well, that's that number or that constant at the end. There it is. As a point, this is my y-intercept. Remember that your x value for your y-intercept is always 0. So I'm going 0, and then up 3. All right, so now that I have my y-intercept graphed here at 0, 3, we are going to identify my slope. So my slope in this case, that's my m value, that's the number in front of the x, and my number in front of the x is the -3. So remember that slope is rise over run. When you have a whole number like this, we're going to put it as a fraction. We always put it over 1. So if you don't have a fraction, put it over 1. That way you know how many units to run or to move in the x direction. You'll always move in both directions. So from this point, from the y-intercept, you always go back to the y-intercept. We're going to graph the slope. So my slope is my rise is down 3. So I'm going to go down 1, 2, 3, and I'm going to go over 1. There's my run. Here is my second point. Now I have my line. I can go ahead and plug my 2 points in, and voila. There is my graph, just using the equation of this line that was written in slope-intercept form. All right, if you feel like you have a handle on that, now would be a great time to pause and try this one on your own. If you feel like you still need to watch another example, then just stick with me. So we're going to do the same thing, same process. Here is my equation, y equals 3/4 x minus 6. I'm going to begin with my b. Remember, your b is that number at the end. It's that constant term. I'm going to pull that out. I have to keep the sign. Since it's a negative, I keep the negative. So my y-intercept is -6 or 0, -6 if I were to write it as a coordinate. So there's that point graphed. Now I'm going to use my m value. That's my slope. That's the number in front of the x. That's my 3/4. This is my rise. This is my run. They're both positive. So from my y-intercept, remember we always go back to that y-intercept, that's step 2, starting from the y-intercept. I'm going to apply that slope. So up 1, 2, 3, and then over 1, 2, 3, 4. And I went in the positive direction both times because both of these numbers were positive. So here is my new point, and now I can graph my line, which is step 3. All right, so what did we learn today? We learned how to draw graphs of lines given a linear equation. So this is when we did our table. We picked 2 points, x comma y, and a lot of times we pick 0 and 1. Finding the x and y intercepts of a line given the equation of a line. Remember your x-intercept, y equals 0 at the x-intercept, and x equals 0 at your y-intercept. Determining the slope of the line. Remember, slope is rise over run, or it's your y2 minus y1 over x2 minus x1. It can also be described by like positive and negative. We've got our horizontal and vertical lines. Here your slope is 0, m is 0, and here your slope is undefined. This is a positive slope and a negative slope. And then lastly, we can graph lines in the coordinate plane from slope-intercept form. And we really just need to focus on the y-intercept and the slope to graph our line. So that's a recap of all that we did today. Okay, so what's next? Today you are going to finish the checkpoint 1.3. It's going to be in the OHS. So after you've watched this lesson, you need to do your checkpoint 1.3. Since all of our classes and stuff were totally shifted around, you might be in a new section today. The first checkpoint is going to be optional, the one that we did on Friday last week, and then this is going to end up being your first graded assignment for this semester. So you want to make sure that you get that checkpoint finished today. Again, it's going to be in the OHS. I'll have all the details in the email to you as well and the announcements. So hopefully you'll be able to find everything. And then I can't wait to get to meet everybody tomorrow as we continue on with our next lesson. Y'all have a great day.